So let's continue on in our discussion of marginal or labor market marginality. Specifically, we're going to take a look now at the marginal expense of labor, which we'll see will look very different than marginal revenue product of labor. So we've included then our basic values that we've already put together. These are from the table values and the first several segments of this series. These values have nothing to do with the two equations that we used in the marginal revenue product of labor and labor demand relationship, trying to look at how those are similar. We're back to the original values that we've been using, so those equations have nothing to do with this part. And we're remembering that we have our basic rules here for marginal product of labor, marginal revenue product of labor, and now we want to take this to some marginal expense of labor. The way that we're going to do that is to kind of extend this by adding some additional columns based upon some additional information, which will be thinking about the marginal expense of labor being equal to some change in total cost of labor divided by some change in labor units. Well, we need to identify total cost of labor then. So the total cost of labor is going to be equal to whatever our labor units are times our wage. So that's pretty simple. So if we extend this out to include wage, total cost of labor, and marginal expense of labor, then that should give us these values and we can see what this might mean to us. Well, let's assume in this case that this is a competitive market for labor. Again, that just means there's some labor supply and labor demand relation that reach an equilibrium, and wherein we get some W star and some L star. And in this case, the W star is 10. So if we're looking at a firm, which is what we would be looking at this point, that firm will be hiring its workers at $10 per hour, in this case, let's say, regardless of whether it's one worker, two workers, three workers, because they have to pay whatever the market price is for labor in their market. So we have a wage of 10 coming all the way down. So the total cost of labor is going to be labor times wage. So in the first case, 1 times 10 is 10, 2 times 10 is 20, and then, of course, we have 30, 40, 50, and 60. So then, similarly, if the total cost of labor change is constant and the labor change is constant, then we're going to see our marginal expense of labor is relatively constant. We're going to have a change of 10 divided by a change of 1 is 10. And then a change of 10 divided by a change of 1 is 10. So we have 10 all the way down here. Very similar to what we saw in the actual wage category. Well, let's consider what this looks like. Here we've got the same data that we've identified from our prior information, but let's think about what this looks like graphically with our basic XY graphic, where we have the wage or the marginal expense of labor or the marginal revenue product of labor, any one of which can be measured on this axis because they're all currency denominated, and we have labor measured on this axis. Well, we already know that we have some marginal revenue product of labor relationship that looks a little bit like this, MRP of L. And we have wage that's constant regardless of the labor unit, so that's going to look like this. So that's wage, which in this case is the same thing as ME of L, or marginal expense of labor. And here at this particular point, we know that MRP of L is equal to ME of L. So that should inform us of some preferred quantity of workers, we'll call it L prime, that we want to hire. Well, in this case, as we've hired one worker, or rather 4 workers, we know that that actually gives us a situation in which the marginal revenue product of labor is actually greater than the marginal expense of labor. So 4 workers would be here, 5 workers would be here. It's going to create a situation that looks something like this, in which we don't perfectly meet that equality, but you'll be able to see then why the inequality of the greater than part of this is important. So here at 4 workers, we're actually receiving a marginal revenue product of labor that's higher than the wage, which means we have a little bit of margin or surplus profit that's left for us. That sounds good. Here at 5 workers, we actually have a revenue that's less than the wage or less than the expense, less than the cost, less than the marginal cost. And that's not good because that's designing a loss at that point. So we would stop then hiring these workers at 4 units. If we had to hire even increments of 4 or 5 or 6, because we don't want to go to 5 and lose money. If we could hire just portions, we might be able to see that this was 4.5 or 4 1/3 or something. What we know is it's somewhere between 4 and 5. And if we spend enough time up here and giving some incremental changes, we could figure that out. Well, what happens when the wage is not constant? And what happens when we have a very different looking marginal expense of labor graphic? So let's think about that. We know here we had our equality, and it was based on these rules. So let's think about what happens when we don't have that equality. What if our wage is actually changing? What if our wage starts at 10, and then, like a normally upward sloped labor supply curve, to have more workers, we need to offer a higher wage. So for 2 workers, it's 11 per unit, or for 3 workers, 12, 13, 14, and finally 15. So if this is our wage environment, now we have an upward sloped labor supply curve for this particular firm, which would suggest that the firm and the market are relatively similar. This is going to be a condition that we think about as monopsony. Monopsony, all one word, and we'll discuss monopsony in great detail in another series within this course. So let's at this point just go ahead and figure out our marginal expense of labor from how we know to create that. So 1 times 10 is 10, 2 times 11 is 22, and then we have 36 and 52 and 70 and 90. So the change in the labor, or change in total cost from 0 and 0 divided by change in labor is going to be 10. But now we have 12 divided by 1, so 12. And now we have 14. And then we're moving to 16 and 18 and 20. So now we're going to create a marginal expense of labor relation that looks similar to, but won't be right in line with the labor supply equation or the labor supply curve. So let's think about what that looks like. It's going to present itself something like this. So we again have wage, or we have marginal expense of labor, or we can say marginal revenue product of labor on the y-axis, some labor on the x-axis. We've already identified that we have some marginal revenue product of labor relationship that looks like this. But now we have to think, what does this marginal expense of labor look like? Well, it starts at 10 and goes to 20 as labor goes from 1 to 6. So it looks like it's upward sloping now, which makes sense to us. Marginal expense of labor. And at this point, they are the same, where we have marginal revenue product of labor being equal to the marginal expense of labor. So we're meeting that general condition at some labor units. And I've tried to get those to match up nicely. They don't look really good there, but I'll let you think that that's matching up with our transection of ME of L and MRP of L. So we would want to be there. But if we look at our values again, we see that at 4 units of labor, we have a wage of 13. We have a marginal revenue product of labor at 25, a marginal expense of labor at 16. So we're still where the revenue is greater than the cost. That's good. But in this case, we aren't actually hitting this perfectly. We are just as we saw in the last case. So here at 4 workers, let's say we have 4 here once again and 5 here once again. This was our L prime. At 4 workers, we're actually in a situation where the marginal revenue product of labor is slightly greater than the marginal expense of labor. At 5 workers, similar to the last situation, we have this such that at 5 workers, the marginal revenue product of labor is now 0. The expense is 18. That doesn't sound good. No revenue but cost. That sounds like losing money. So we're going to once again stop at the 4 workers. But here's something interesting. At 4 workers, we get this productivity out of them, which let's call it MRP of L prime. But we have this marginal expense of labor, which is yet less, which we know that that is 16. So down here we're at 16, and we'll call 16 is equal to marginal expense of labor. But in this case, because of what we actually have to pay the worker, we're only paying them 13. So now marginal expense of labor does not equal the wage. Marginal expense of labor is greater than the wage, or the wage is less than marginal expense of labor. Both of them are less than marginal revenue product of labor. So in this case, this firm is profiting yet more because, in this case, that monopsony relationship that I referenced.